interesting placement question here. So we've placed 1, 2, 3, and 4, and then we're trying to place 5 to 36 in the remaining 32 empty squares. And we want to show no matter how this is done, we're always going to get a pair of adjacent squares that differ by at least 16. So if we put any of the numbers 20 to 36 adjacent to 1, 2, 3, or 4, then we would have failed. Basically, we're trying to do it without. So basically, we're going to try to not put them next to it. So yeah, I suppose that's the first thing. Try to place 20 to 36 so they are not adjacent to 1 to 4. There are 17 numbers to place. Because it's 36 minus 20 to give 16, but then you have to add 1 on. There are 21 to 36 is 16 numbers, 20 to 36 is 17 numbers. So how many places are there where we can fill them? We could count them. So these are all the squares that are not adjacent. Okay. Oh, sorry. That one's adjacent and that one's adjacent. My bad. Then we've got 4. We've actually only got 16 places. But, and that's the problem with this question, but there are only 16 squares that they can be placed in. At this point, it's a little bit like musical chairs, if you've ever played that. We take away one, we have a certain number of people, a certain number of chairs, but there's always one less chair. And so somebody at the end of the round, when you've stopped the music, is not going to be able to sit down. Same thing here. These numbers, you can imagine them moving around. But there's only 16 places for the 17 of them. So one of them is going to have to go in one of these squares that is adjacent to 1, 2, 3, or 4. And at that point, you're necessarily going to get a difference between those two of at least 16. So 16 squares that can be placed. And therefore, it's not possible. Like at least one number um, between 20 and 36 inclusive must be adjacent to 1, 2, 3, or 4. And that's it really. No matter how we place them. We've tried to place it to avoid it, but there's only 16 places where we can put them. There's 17 numbers, so it's not possible. One of them must end up next to 1, 2, 3, or 4, which will give this difference of 16. As long as you can explain that, argue it, quite a short argument, that is how you solve this question. Well done. Just a final little shout out at the official answers. They do it in a slightly different way, to be fair. They, in fact, look at the adjacent squares and then try to fill it in. So they managed to put in the integers, well, they tried to put in 5 to 19, but then once you have filled them in, then there's going to be one square left over, always, necessarily, which you're going to have to put 20, okay, if you're working your way up, or one of the higher numbers. and that will again cause this problem. So yeah, I argued it by trying to avoid with the higher numbers. This one is trying to fill in the lower numbers, but in both cases we get the same issue. That's the crucial part of this argument that you have to get across.